Thank you, nice introduction. So today maybe my talk is give some partial explanation for special questions why home advantage not works for some issue and also some causal inference framework. So this is a joint work with my previous master student and my collaborator in UC Irvine and in Hong Kong universities. So first, what is the home field advantage? So that is very important stuff in all this kind of competition in all the sports. So that means the home teams win more often than visiting team across different sports. Not only in soccer, we will have this kind of in the basketball, baseball, or other, or maybe genetics, this kind of stuff. And also, there are a lot of empirical studies shows that there are some persistent performance advantage when teams play at home, right? And also, this kind of stuff observed across different leagues, not only some in the La Liga or in the EPL or in the Liga 1s, and also across different seasons. Maybe sometime, maybe before the pandemic, if we have more audience, maybe we have more home advantages, but during the pandemic season, maybe we have less home advantages, and also have some competition formats. So this is some summary study for this kind of home field advantages. So in the American footballs, so maybe there will be nearly 60% of winning rate in the home teams in this kind of American football, and also in the soccer, this kind of winning rate will be higher. But that just the winning rate. But also in the NBA, we have more this kind of stuff. So that means the visiting team will score 2.8. fewer points, and also attempt two fields free throw and make one field free throw. So that will be this kind of compared to their season average. So that will give you some sense why we will have this kind of home advantage based on different angle of the result and statistic during the games. And also, if this sports with more than 100 games per season, that will exhibit significantly less home advantage than sports with fewer than 50 games. So that will give you some idea that is, if we have some baseball, maybe that home field advantage will be vanished during this kind of long season, but in some short season like the American football or the soccer, and the game is limited during one season. So that will have stronger or more significant this kind of home field advantages. So why does home advantage exist? So that gives you some reason. The first thing, also very important thing, that is crowd involvement. So that will be, since for the away team or visiting team, we will have some psychological pressure on visiting team. So that will obviously, for example, my home team is the Barcelona's. We know that the Camp Nou has over maybe hundred thousands audience for that one game. So that will give you a lot of pressure for this kind of away teams. And also that will increase the motivation and energy for the home teams. So that is very obvious pattern. So also that is a lot of study will find that during the pandemic season, there will no longer be any this kind of home advantages, and there are no audience during one stadium, for one stadium. The second thing, that is travel fatigues. Also that is very important. Also that is a story I learned maybe 15 years ago. That is in 2009 to 2010, that Champions Leagues. So in that time, Barcelona cannot fly to the Milan. So the Barcelona just need to take the bus to the Milan. So that may make that away games the Messi and all the players not perform very well. So that is very important. So that will have some physical exhaustion for this kind of visiting teams. And always we will find that if some team go to some away game, they stay at some hotel. Maybe some football fans or soccer fans will go to that hotel, make some noise during the night. That will make them not sleep well. So that is also very important. And also they will disrupt some routines and recoveries. And also, since in the home game, they will have better this kind of facility to do some recovery for some games. And the third thing, that is familiar with the facilities. So that also is very important in the soccer game. Since we know that if we have longer grass, maybe the ball movement will be slower. If we have shorter grass, the ball movement will be the faster. And also we can give different water to the grass. So that makes a difference. And also very similar thing for this kind of size of this kind of field, also a little bit different. For example, I think we have some fans for Liverpool. Definitely we know that the Anfield will be a little bit smaller than other stadiums. That is the open secret for the Anfield. But so that will make a little bit different for some defense strategy teams. And if the stadium is smaller, that will be better for this kind of defense strategy team. So that is this kind of stuff. And also sometimes they will have some visual or the spatial clues based on different this kind of stadiums. That fourth thing will be the referee bias. So that is very important in all these kind of games. So that since most of these kind of referees will be more favorable calls for the home teams instead of this kind of away team. So that is some general cause this kind of home field advantages. So, but in the previously there are some statistical evidence on this kind of home field advantages. So in this kind of paper they show this kind of Champions League the home field advantage decreased by this kind of 1.7. Suggest that home field stables over time. So there will not much more change over time. And also, they will have some indicate some structure rather than transition effects. And also, there's some other paper that means they show that is on average the home field in soccer equivalent to 0.6 goals per game. So that is facility familiarity, especially important in faced in the pace sports. But in this kind of paper, they only do some simple this kind of summary statistics or this kind of correlation analysis. So that is some data potential data is more correlated analysis, but there are no existing work for the causal inference framework. And also they focus on some very obvious this kind of summary statistics in the soccer, for example, number of goals or this kind of stuff. So there are some challenges for this kind of home advantage causal inference. The first thing that is this: if we analyze in one league, for example, EPL data, that is obtained neither from the randomized trial or this kind of observation study. That is very important two cases in the causal inference. So if you're familiar with the causal inference framework, always people can do some randomized trial, like in a clinical study to detect some causal effects, or using these kind of observational studies to randomly assign each treatments. But these two standards is not exist in our sorted analysis. Since we have schedules for 1 year data seasons, so that we cannot treat that as a randomized trial. We cannot simply randomize each team to home and each team to away. So that is the thing. And also that is not purely observational studies since we have schedules. So that is some challenge for this kind of soccer data analysis. And also there are another very important thing that is there is one team with home advantage, but the other one should not in the neutral field. That is that they have this kind of home disadvantages. It's away disadvantages. So in the legal level data, there are no match in the neutral field. That is also another important challenges. So our goal in this kind of project that is we want to do some pairing analysis for solving this kind of causal inference problem. And also another very important thing that is that Sabash mentioned that is we want to do some causal effects and identifiability, this kind of identification and to estimate, but we want to do both this kind of legal level and team levels. So we want to know on average this kind of England Premier League has how much this kind of causal effects, and also based on different team how much causal effect they have. That is what we want to do. So our motivating data is one season, maybe with most limit home advantage, that is from 2020 to 2021. I think in that season in England Premier League, the average data attendance for the game is around 10,000 for each game. And in that season, we will find some very interesting thing that is the number of home winning is a little bit less than the number of winning in the aways. So that is for that season. Also, that is because of this kind of pandemic stuff. And also, the number of goals scored in that season is very similar with this kind of number of goals scored for the away this kind of team. So that gives you some idea. We cannot just use this kind of winning or losing or number of goals is our targeted response. Since in the soccer game, that is too random. For example, in the England Premier League, for example, if we know the Damian Martinez, that Argentina, that goalkeepers. In a lot of games, he performed very dominant. Maybe the opponent create a lot of chance, but he can put that goal away from the net. So that means this kind of winning and this kind of goal score is not a good target to identify this kind of causal effects. So what we do is we not focus on this kind of too obvious this outcome in the soccer games. We do this kind of more macro data set. For example, the number of attacks with shots. This is some obvious, this is the offense statistics, and also we have some this kind of defense statistic, and also we have this kind of expected goal, and also the yellow cards to define as this kind of referee, this kind of bias. So that will give you some idea how this kind of causal effects have some macro impacts on some summary statistics during the games, not only for our final result and number of goals. Okay, so the main framework of our study, that is, we first define the net differences in the outcome interest. So that is, we have team I and team J and a certain outcome. So we have this kind of team I in this kind of game, we have 10 attacks in the box, and the team J have maybe 8 in the box. So that is, we do this kind of difference. So in the causal inference framework, very important thing that is our potential outcome. So that is, we have delta I is our treatment. So that is the treatment for I's team, and also we have delta J is a treatment for the J's team. So in our soccer game, if we have delta I is the home, definitely delta J should be the away. We cannot observe 2 teams in home, 2 teams in away. So that is very important thing. And then we can define our potential outcome and the main outcome. So this is 3 assumptions if we want to identify our causal effects. Okay, the first 2, that is from the standard causal inference textbook. So you can easily find that from the Rubin or Inference textbook. The third thing, that is, we customize this kind of assumption is fit to our sports analytics. So in the traditional this kind of causal inference framework, they would have an assumption called that monotonicity. But in the sports, we should not assume that. So that is, in the sports, we can easily always observe maybe team A can beat team B, and team B can beat team C. But if we have the monotonic assumption, definitely team A can beat team C. But in the sports, always we will find that we will have some triangle, this kind of situation. Team C can beat team A. Right? For example, in the England Premier League, maybe we will observe Man City can beat maybe Manchester United, and Manchester United can beat Arsenal, Arsenal can beat Manchester City. Maybe that is this kind of situation. So we cannot have this kind of monotonic assumption. So here we have this kind of non-monotonic assumption that is more better fit to the situation in our soccer games. So how can we do the estimation for our causal modeling? So our causal modeling data is, if we want to estimate the causal effect of the I's team, that is, we need to take the expectation of all these kind of potential outcome for I's team versus J's team minus they are in the neutral stadium. So that is what we want to estimate. But the very important thing that is, we cannot observe this, since we do not observe both teams in this kind of neutral stadium. So that is what we have. So, and for this kind of, on average, this kind of legal level causal effect, we just take the expectation over all the teams. So that is what we want to estimate. This is our target estimates. But how can we do the estimate? That is the question. So we build this kind of simple model. So we conditional all rest of condition. So that is what we build our simple models. So Yij is their net difference. So alpha ij is their latent ability difference. We consider all this kind of situation. So we do not want to have too complicated model. And beta I is our home field advantage. So that will, and plus certain error term. So we will have our observe their net difference outcome. And so, and in the legal game, we have very good thing, that is, team A will play team B in team A's home stadium, and also team B will play another game with team A with the team B's home stadium. So still we have this kind of YJI. So this is the J and the I's, their net income. So here, their ability difference becomes negative alpha ij, and plus beta J is the team J's this kind of home advantage plus another error term. So that is what we have. And also another thing we assume that is we have this kind of beta I follows normal, delta. Delta is our legal levels, this kind of team effect, the home field advantage effects. So that is what we can have for this kind of model. So based on the model, our target is we want to estimate all this kind of beta and this kind of delta. That is what we want to estimate. How can we do the estimate? So here we do a very simple thing. We just do the summation for equation 3 and equation 4. This kind of alpha all cancel out. So we have this an h times beta plus epsilon equals to y. So if we treat this h is our x, so this model becomes to y equals to x beta times epsilon. So the estimation for beta, we just use our ordinary square. That is very simple and straightforward estimation. So then what we can have, just based on our linear models techniques, we can estimate this kind of beta hat. And then our payload estimate for delta hat is just to do this kind of mean for this kind of all beta hat estimates. So that is our estimation, so that is quite simple. Then what we do is, since we get estimate, we still need to construct confidence interval, so we can use our linear model strategy to find the confidence interval for all these kind of beta. So that is the first thing, and also we can find the estimation of this kind of sigma square, then we can do the inference on this kind of delta. So that is what we can have for this kind of stuff. And then this is, we just can think about the statistics individually, and also we can do that is we can stack all these kind of statistics together. So our previous linear regression model univariate linear regression model becomes to a multivariate linear regression model. So that is what we have. So here, this kind of y is this kind of k different, this kind of summary statistics, so that all this kind of beta is this kind of matrix. Then, based on this kind of multivariate linear regression model approach, we can have this kind of estimator, and also we can get all this kind of confidence band for this kind of estimator and this kind of legal levels, the estimators, that confidence band. So that is what we can have, and also all these techniques that it comes from our linear regression model and the multivariate linear regression model. And then that is our individual study stuff, so we can get our legal levels estimation and the variance estimation, and also we can have the p-value. Here we can still find there are some very significant results. For example, we have the X with shorts and this kind of reaching opponent's half, and also this kind of XG has some significant result, but this kind of yellow card does not have any significant result. So that is this kind of team level, this kind of p-values, and this kind of team levels estimate. This is the confidence band for each team. So there are some findings that is some offense-based statistics, such as attacks with shots and reaching opponent, that is the most significant, but this kind of defense summary statistics, they are not that significant, as well as the referee-based this kind of statistics, like the yellow card. And another thing we find very interesting, that is there are some less performant team will reap higher benefits of home advantage than this kind of team that excels. So that is some finding. We have this kind of univariate analysis, but still we do this kind of joint analysis, that is multivariate analysis. So that is our estimation. So this is the result. We find that maybe that 95% confidence interval that grouped by the performance matrix, and also there are some heterogeneity in the home advantage across different teams, and some middle level or low ranking in that season. We know that Newcastle now is a good team, but in Destiny not that good. That shows some stronger home advantage in multiple dimensions, and some top team like the Manchester City, Manchester United, Liverpool in that season that will have a smaller negative distant home field advantage. So that is what we estimate on average, and this kind of legal level stuff. This is the correlation we estimate for this kind of all 11 summary statistics. So there's some discussion, maybe. In the universe study, we do not consider this a multiple testing issue, so maybe we need to do some FDR control, and also we do not analyze this kind of COVID effects in that 2 seasons. And also, recently we are working on that is how can we do some real-time analysis over time. So this is the relevant paper, so if you want to check more statistical detail and more simulation study and math study, you can check this kind of paper. Finally, welcome to join our ASI Study in Sports session. So we will share not only the soccer, but also other sports. That's all for today. Thank you.